This is lesson 1, horizontal and vertical translations. So in this lesson, we're going to go over the note package that I provided you and go over the examples. And then at the end, you'll have the opportunity to do some of the practice questions in preparation for class the next day. Now, what we're looking at in this unit is how graphs change when we do operations to their functions. So we have some terminology here. The first term is transformed. The function g of x obtained from transforming the original function f of x. Okay, so f of x and g of x are just names for the functions that we're working on. Now, the first thing that we're working on is transformation. Think of it like, if you go on a weight loss journey, you're transforming your body. It's a change. Okay, or you're transforming your life. Any change that's made is going to create some changes on the graphs. So the transformation is a change made to a figure or relation such that the figure or the graph in the relation is shifted or changed in shape. Okay, and the way that we're going to do that is through mapping. So what we're going to do is compare one set of data points to the other and figure out how have they changed. So the first type of change that we can have is a vertical translation. They're typically done in this format: y is equal to f of x plus k, where k is the vertical change. So, for example, if we have y is equal to f of x plus 4, where k equals 4, this is a vertical displacement upwards by 4 units. So we would just add 4 units to each value of y and the graph moves up. Comparatively, we have this function y is equal to f of x minus 3, where our k value is equal to negative 3. This is a vertical displacement downwards by 3 units. So we just subtract 3 units from each value of y. The graph moves down. Now, I'm going to talk about on your notes this example right here on the left-hand side, base equation f of x is equal to x squared. So we have f of x is equal to x squared, and that's going to be the purple line shown here. Now, we have this graph of this parabola, and it continues on indefinitely. So if we're talking about the domain and range that we quickly reviewed, our domain, which is all our x values, continues on from negative infinity all the way to positive infinity. And the arrows on the lines here can tell you that it continues on outside of your graph. Now, on the purple line, which is our base function, f of x is equal to x squared, or y is equal to x squared, we want to look for some key points and see how have those points changed on our g of x. So this is a really good point to start at because it's going through the vertex. This point is, of course, x coordinate 0, y coordinate 0. Now, let's just look for a few other ones on this graph that go through a solid line really nicely. We'll look at this point here and this point here. Notice that it's mirrored across the y axis. So right here we have this point, negative 2, positive 4. And here we have positive 2, positive 4. Okay. Now we're looking at a vertical translation. And what we're going to do is look at how has this graph, these points, moved up or down on the graph to figure out what our transformed or g of x will be. So we're looking for k right now, the value of k. If we look at this point, we can notice that it's gone up 1 unit, 2 unit, to this point right here, 0, 2. And we can also compare these points that we looked at earlier, this one and this one, And we can see that they've also gone up 2 units. 1, 2, to this new point here, -2, +6. And this one does the same. It goes up 1, 2, +2, +6. So when we are looking for or mapping out the new coordinates for the function g of x, the black line, we're going to get a formula that looks like this. You can write it either of these two ways. The first one is g of x is equal to f of x, our original function, x squared, plus 2. We're moving it up 2 units. Or alternatively, you can also put it as x squared plus 2, just showing that the graph is moving up 2. So this here is our value of k, plus 2. Now our new coordinates, it's very simple. You just look at your original graph. All the x values are going to stay the same. They're not going to change. But all your y values, you're just going to add 2 to each of them. Now we're going to consider this graph right here and look at how a negative k value will change the graph for us. So again, we're using that base equation f of x is equal to x squared, and we're going to look at the transformation that happens. So you want to do the exact same thing that we did in the previous question. Look for key points that go really nicely and clean through any coordinates on the graph. So here we have 0, 0, and let's just take 2 other points. Again, we'll use -2, 4, and +2, 4. So in this example, we're still trying to find that k value, and we do it by just counting on the graph. So let's look at how this coordinate 0, 0 has changed. This coordinate here, if it's available to you, can be a really good indicator of what has happened to your graph, because it will allow you to see very clearly how many times the function has shifted. So if we just trace down, -1, -2, -3, we have this new point for the vertex of our parabola. It's 0, -3, and we can compare these as well. They're going to move the same amount of units down, comparing these ones. So -2, +4 moves down 3 units. 1, 2, 3. We now have -2, +1, and the same thing here. 1, 2, 3, and +2, +1. So we can see that all of the y coordinates in this graph have shifted down 3 units, and therefore our k is equal to negative. When you look at the transformed function g of x is f of x minus 3, or g of x is equal to x squared minus 3. Our new coordinates again are x. All the x values stay the same, and the y values are now, oh, excuse me, that's an error. It should be y minus 3 to give us our new function. The next section that we need to consider are horizontal translations. So we can move the graph up and down, but we can also move it side to side. So here we're going to be manipulating the x values to change the location of the graph. So for this function, for example, we have y is equal to f of x minus 2, where h, you can see right there, is equal to 2. So it's a horizontal displacement. Horizontal means side to side, right, by 2 units. So notice when this is negative, we're moving right. What we're going to do is add 2 units to each value of x. The graph moves 2 units to the right. Now in this one, we have y is equal to f of x plus 4. h is equal to -4. When we're moving in the negative direction, we're moving towards the left. Notice that it corresponds to the negative and positive values on the x and y axis. If you're going more negative, you're going further away from 0 to the left. If you're getting more positive, you're getting further away from 0 to the right. So we're going to use that same base equation again. F of x is equal to x squared, just our basic parabola. And we're going to compare two different g of x horizontal translations. So in one of these, we're going to compare f of x minus 5. And on the other one, we're going to compare f of x plus 2. So the graph will look like this. Nothing has changed in the shape of the graph. Here's our original y is equal to x squared. That's this one right here. We have that nice vertex point again, where we have the point 0, 0 on our graph. If we just look solely at the vertex, we can see that the whole graph has shifted. For this function, it's shifted 2 to the left, 1, 2. Our new function is 0, or excuse me. Our new function is -2, 0. Okay. And you might be saying to yourself, well, the function is y equals x plus 2 squared. Why has it moved to -2, 0? And the reason why is because you have to remember that this -2 is the value of x. So when we have, I'll work down here, y is equal to x plus 2 squared, and we say x is equal to -2, fill in that value, -2 plus 2 squared, y is equal to 0 squared, y is equal to 0. Okay, and that makes sense. That gives us our coordinates. When x equals -2, y equals 0. Now on the other parabola that we're looking at, we've shifted over 1, 2, 3, 4, 5 units to the right, and our new point is 5, 0. And so it's a very similar situation to the other. We want to say, what is the value of x when y equals 0 to figure out this point? So we would just plug it in exactly the same way as we did down here. +5, 5 minus 5 is 0 squared when y equals 0. That will give us our coordinate 5, 0. So at the end, you can see that we have these new coordinates, x minus 2, y, as well as x plus 5, y. So your y values do not change. The shape of the graph does not change. It's just moved over left or right. The last thing that we can do is determine the equation of a function obtained by translation. So we have something called image point, the point that is the result of transforming the transformation of a point on the original graph. We have a couple steps. Step number 1 is to determine the base function. And then step number 2 is to choose significant points on the graph and locate the corresponding image points on the graph of g of x. So what we're doing here is exactly the same as we've done in the last two. We're just looking at how far up or down or how far left or right the graph has moved. This is example A. Our base function f of x is equal to x squared is right here, this blue line. You can see here the function is given, f of x is equal to x squared. Okay. This red line here is g of x. So exactly like we did in previous examples, we're going to use some reference points, image points. So here's our 0, 0, 0.00, and that is going to shift over. We're going to look at how has it moved. Moving this 0, 0 point can be a really good indicator of what's going to happen to the rest of the graph. And we can see how that will work by tracing the horizontal displacement as well as the vertical displacement. So we're going to go from 0, 0 over 1, 2, 3, 4 units to the left. Okay, so now the vertex of this parabola is at -4. And we're going to see how far down did we go from our original 0, 0. So from here we're going down 1, 2, 3, 4, 5 units. And here's our new point. Our new point from 0, 0. So I'm just going to clear this up. 0, 0 has moved over 4 to the left and down 5. So our new point is -4, -5. Now, you can compare all the other image points that are provided here, but what we'll see when we compare the points, so for example, if you take +1, 1 and do that same thing, just trace it down and trace it over, you'll see it also moves down 5 and over 4 to right there. Okay, and all the other image points that are given, that exactly same thing will happen. So we have our original x, y, and what's happened is all the x's have gone down 4 and all the y's have gone down 5. Now, when we want to write out our equation g of x, what we're going to do is recognize that for the value of k, it has gone down 5 units, and for the value of x, it has shifted 4 units to the left. Notice that the sign changes here. It's x -4. That's what's happened to the points. So the point has gone from 0 down to -4. But in the brackets, the function g of x is x plus 4. Because when we plug that value of x into there, that's what's going to give us the 0 for the other value for the new y. Okay, so that's that example. Now, we've used parabolas so far, but it doesn't work exclusively on parabolas. It works on any kind of graph. So in this example, we have a base function. It's non-linear, it's point to point. So we would just call it f of x. And what we're going to look at is how has this graph moved? You'll notice some things on your diagram there in your notes that we've listed the letters A and then A prime. A prime just means that's the new location of A. So we've done that for all the letters here. You see that in your notes. The exact same thing that we've done in the previous question we're going to do here. We're going to pick a reference point and see how has it moved to get from this original point down to this new point here. We're going to look at A and A. Now, if you look at the original A and the f of x, you can see that it's now moved over to the right 1, 2, 3, 4 units. Okay. And then if you look at how far down it's moved, you can see that it's moved 1, 2, 3, 4, 5, 6, 7, 8, 9 units. You can also see this difference if you take the difference between the new and old coordinates. So the difference between -5 and -4, the difference between 2, -7 is -9. And that will give us our new xy coordinates. Xy changes to x plus 4. It's moved 4 to the right. Remember, to the right is a positive change. And then y minus 9 has gone down 9 units. So when we determine our new graph, g of x is equal to f of x minus 4 minus 9. This same thing that we've done here, it will work with any point on this graph. So for example, if we looked at point E, which is starting at 3, 3, you can see that it's now moved over 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8, 9.